What does the discriminant tell us about a parabola? Imagine you're looking at a graph of a quadratic equation and wondering how many times it crosses the x-axis or if it touches it at all. The answer lies in a small but powerful number called the discriminant. The discriminant is part of the quadratic formula, which helps us find the solutions to equations like ax squared plus bx plus c equals 0. It is calculated as b squared minus 4 times a times c. This number tells us a lot about the shape and position of the parabola without actually solving the equation. If the discriminant is positive, it means the parabola crosses the x-axis at 2 different points. Think of it as the graph cutting through the x-axis twice. If the discriminant is 0, the parabola just touches the x-axis at 1 point. This point is called the vertex, and it is where the parabola reaches its highest or lowest point. When the discriminant is negative, the parabola does not cross the x-axis at all. Instead, it stays completely above or below the x-axis, depending on whether the coefficient a is positive or negative. The discriminant also helps us understand the nature of the solutions. When it is positive, the solutions are to different real numbers. When it is 0, there is only one real solution, which is called a double root. If the discriminant is negative, the solutions are to complex numbers, which involve imaginary numbers. The value inside the square root in the quadratic formula determines whether the solutions are real or complex. If the discriminant is greater than 0, the square root is a positive number, giving us to real solutions. If it equals 0, the square root is 0, resulting in one solution. And if it is less than 0, the square root involves an imaginary number, meaning no real solutions exist. So, understanding the discriminant helps us quickly predict how a parabola behaves and how many solutions it has. It is a simple calculation that reveals whether the parabola crosses the x-axis, touches it, or stays away from it entirely. This makes the discriminant a handy tool for anyone working with quadratic equations and graphs. Instead of solving the equation first, you can use the discriminant to get a clear picture of what the graph looks like and how it interacts with the x-axis.